back to An Afternoon with Newton. In this episode, Isaac Newton, well, Danya Shakur, is going to explain how his 3 laws of motion apply to some of his favorite activities, bowling and
swimming. Now, there's more to bowling than you think. Let's start with my first law, the law of inertia. This law states that every object continues in a state of rest, or at uniform speed in a straight line, unless acted upon by an external or outside force. That basically means that an object at rest, or in motion at a constant speed along a straight line path, will stay in that state unless an outside force is applied to it.
so that means that objects naturally tend to keep doing what they're doing.
Down the alley. Assuming it is going at a constant speed in a straight line, you'll notice that it'll then collide with the bowling pins, changing its state of motion. In this example, which demonstrates my first law, the bowling pins, or the outside force, act on the bowling ball, which was going at a uniform speed in a straight line. The bowling ball's acceleration decreased because of the bowling pins, which is the external force. Can you think of another example of bowling that demonstrates my first law?
Yeah, the bowling pins, which are at a state of rest, are disrupted once the bowling ball hits them. In this case, the bowling ball is the outside force. Then, the bowling pins are temporarily in a state of motion until they assume their new state of rest.
Your second law is about. It's about force and acceleration.
This law states that the acceleration produced by the net force in an object is directly proportional to the net force,
is in the same direction as the net force,
and is inversely proportional to the mass of the object.
The equation that goes along with this description is A equals F over M. Exactly.
So, in other words, the greater the mass of an object, the more force required to accelerate it, and the more mass of an object, the less it will accelerate for a given force.
For example, there are several bowling balls, each of different weights and masses.
Mass is proportional to weight.
Newton's second law tells me that it requires more force to accelerate a more massive ball than it is to accelerate a less massive ball.
If you roll 2 bowling balls, assuming you're using the same amount of force each time, and one is more massive than the other, then the less massive ball will accelerate more than the one with the greater mass, right? Right. action states that whenever one object exerts a force on the second object exerts an equal and opposite force on the first object.
So, whenever you apply a force to an object, the object responds with an equal force in the opposite direction.
As I descend the stairs into the pool, my foot exerts a force on the stairs. The stairs exert an equal and opposite force on my feet. Also, when I'm swimming, I push the water and the water pushes me, just in an equal and opposite force.
Well, that's all for today, folks. Thanks for watching An Afternoon with Newton.
Oh, Isaac, your hair is just so beautiful. I must love you. He has no eyes. He has no lips either. Romeo, save me. I've been